Welcome to Part 2 of the Competency 7 quiz. We will continue to answer questions related to types and properties of functions. Number 7. Which one of the following rational functions has both two distinct real zeros and a domain of all real numbers? Okay, let's go straight to C and D. Because we know that we need to look at the numerator to decide if we have real zeros. And we need 2. However, we're not going to get 2 out of C, and we will not get 2 out of D. So we look at these numerators, and we see that we won't get the 2 real zeros, distinct real zeros that we need. So that eliminates those 2. Now let's go to A and B. And we can quickly see that A and B will both give us those zeros that we need, looking at their numerators. Now let's look at the denominator. It says domain of all real numbers. Well, we see right here that B will not give us all real numbers. We will have vertical asymptotes at 7 and -7, x equals 7 and x equals -7. So that eliminates B. Well, now if we look at A, we can see that this actually will give us a complex situation. And when that happens, we can't see complex values on our real number line, our coordinate plane. That being said, all we can see is all real numbers. And we can even graph that. So we know A is our option. So let's go back here, clear this out, and we will say alpha y equals, and let's go with the number 1. And it sets up our fraction, open parentheses, 3x plus 5, close open, and we have 2 minus x, close, arrow down, and we have x squared, and then plus 16. Now let's graph that. And visually, let's zoom in. Visually, we can kind of tell, but we've got to zoom in. So let's go with that 6 standard. We can do the standard or the 5 squared. Let's do standard. Visually, we can tell. We could even zoom with a 5 or zoom in. It doesn't matter, zoom to fit. Either way, we can very visually see that we have all real numbers and those nice, distinct real zeros that we needed. Okay, let's move to number 8. Okay, let's go right here. The graph of the polynomial function g of x has 4 distinct zeros, but only 2 x-intercepts. Which one of the following could represent g of x? Okay, let's look at A. That is going to give us 1, 2, 3, 4 distinct. But we can't have that because those are also all 4 intercepts. And it's telling us we only need 2. What this means is that we're looking for 2 distinct, and we're going to have 4 zeros. We'll have 2 distinct, but then we're going to have 2 that are complex, and all complex values come in conjugate pairs. And that's what we're looking for. So let's look at B. I see what could be a conjugate pair. Okay, we're fine. But this is only 1 0. So B won't work. Let's go to C. I see 2 zeros, but I do not see that nice conjugate pair for our complex situation. So C will not work. We have D left. Well, let's hope it verifies. It should. Okay, well, I see 1, 2 distinct real zeros. They're going to cross. And then I see my conjugate pairs. Now, I know for a fact that this will work, and we could even graph this because I've done the math, and I know that if we FOIL these last 2 parentheses, that we have x squared plus 6x plus 25. Okay? Now, you could verify that for yourself, okay? But let's put that in the calculator because that's really what we're doing. We know the answer to the question. What we're doing for this question is let's use our calculator and make sure that we are on the right track. So let's clear this out. Open x minus 1, close, open x plus 1, and open. We have x squared, and then plus 6x, and then plus our 25, close. Let's graph it and see what we get. Ooh, okay. Yes, that does verify. We have all real numbers. It's kind of hard to see, but what's happening, it looks like we have something that's close to uh, a quadratic that goes up, but very slowly. So let's see if we can get a little, let's do a 0, which is a zoom fit. Yes, this looks a lot better. See how we're getting that nice look, that curvature? We could zoom out just a little. So press enter once, arrow down so we can get a little bit better fit. Remember, you got to keep tapping to get that. There it is. Hold it down a little. Okay, let's do enter. There it is. That's that nice curvature. So that tells us we do have all real numbers. Check, check. And D is the option. That's nice when it works out. It's just verifying on the calculator, moving that window around is a little tough sometimes. Okay, number 9. The function g of x has 2 vertical asymptote. Okay, which one of, tiny typo, guys, there we go. Which one of the following is the explicit expression of g of x? Okay, this means which one gives us that explicit situation where we see those vertical asymptote very clearly. Okay, that we need to see with our domain. Okay, and that means to see the domain and see the vertical asymptote, we're looking at the denominator. Well, explicit is the key thing. I think A does it because A can be factored out. I see x minus 10 and x plus 9. I could write a little better, right? Okay. Okay, so I see a factored situation. So I see x equals 10 and x equals negative 9. Okay. However, with B, so I'm thinking that's it because that is very quick and easy to see. That's what they mean by explicit. We identified it right off. B, that's not as easy to see because when I dealt with this and I solved, I actually had a complex situation. So that's not implicit, okay? That's not going to give me what I'm looking for. When they say explicit, they mean factor it out or use your formula. Okay, now here on C, what C is wrong, what it does that wrong that we don't want, we need 2. Well, C only gives us 1, so that's only 1, so that's not going to work. And then as you see here, D, you're looking at the denominator. We have a bit of a predicament, which is that complex situation, because we're going to have x squared equals negative 9. So again, that's not explicit, okay? That's not what they're asking. It doesn't satisfy the question. A will be the only item that satisfies that question. Number 10. The function has a horizontal asymptote with the equation y equals negative 2/3. What is the value of b? Now, let's note our actual function and what it looks like. We have this b here, let's highlight the B and notice the two leading exponents in the leading terms. They're the same. And this question is trying to get you to remember what happens, and they've given you a hint. They're telling you that there is a horizontal asymptote. So that means that we are either going to have m equals n, which we do, so check mark on that, or because we do have a horizontal asymptote, that tells us that we would also have the situation of m less than n. Well, we have the first situation. That's great. So that tells us if they're equal, we need that ratio or rational expression, which for us will be 9 over b. It must be equal to this line, this given line of y equals negative 2 over 3. So now all we do is we just solve this equality or equivalence. So let's do that. So we say 2b equals negative 27 divided by 2 on both sides, and that will give us b equals negative 27 over 2, and that's option D. Okay? Now let's keep some of these rules in mind as we move to number 11. The function k of x has no horizontal asymptote. Well, we've already done number 10, and that's when they're equal. Okay, and then we said, well, m less than n, there'd be some kind of a horizontal asymptote, but what kind would that be? Well, in that situation, that would imply that y would equal 0. Well, that's not the case here. So we only have one situation left. We have m greater than n. Okay, so for us, our k of x, we're going to look at those leading exponents, and we have m, and our n is equal to 6. So this means we would have m greater than 6, and the only option that satisfies is A. Okay? Those two questions were just, do you remember your rules? That's all that they're trying to get is your understanding and memorizing the rules. So as long as you know your basic rules, you'll be just fine. Okay? Now let's go to 12. What is the equation of the slant asymptote for g of x? And here's our rational function. Okay, let's put this in your calculator. So put your y equals. I've already entered it, okay? I'll go ahead, I'll clear it out just in case you don't remember how to enter these. Let's clear this out. And what you need to do, see where my cursor is flashing. You push alpha y equals, and we're highlighted on number 1. That is what we wish. That's what we want. So we have 4x caret up to the third. You will have to arrow over and say minus x, use your square button, and now plus 8. Arrow down, and we have x squared and minus 2. Now let's graph this. Okay, now how did I get a reasonable graph for this? I hit 0 and go up, arrow up. See, I said 0 before I did it. Go down and it's on 1. Go up and you see where it says 0, zoom fit, push 0. And it'll give you what you need. If it doesn't do the first time, try it again. Okay, so what I need, I could do one thing. I could see which one of these works. Slant. I could try that first. So let's do that. Let's go y equals, go down to the next one, and let's say 4x plus 4. Graph that. No, it's off. It's way too high. Okay, So let's go down. Let's try the next one. And let's do +1. Graph it again. It seems to be right on top of this upper part in the first quadrant. I don't like that. Let's go back down. And now C, it says -1. Okay. Let's graph. Ooh, it seems to be just right. But let's not take the cart before the horse, okay? So let's do this one last time and look at the last one. And that's -4. Okay, let's push graph and see what we see. Ooh, way far. Oh, see how it's too far down? Very far down. Okay, but I'm not going to leave it at that. Let's go back and put back the one we want. 4x minus 1. Great. I like the graph. I'm going to leave it there. That's what we've chosen. But let's not just be satisfied with that. Really quickly, let's do that long division that we did in the other videos, and let's prove it to ourselves. Okay? So we have x squared minus 2. And let's divide that into 4x to the third minus x squared plus 8. And that is a 4 is our leading coefficient. Okay, so what do we need to divide this out? Oh, I see an issue. Let's get rid of this for a second. We have a gap. We have x to the third, x to the second. We did not have just x to the first. You need to put a gap in there, a placeholder. Use 0. Now let's proceed. Don't forget you need your placeholder. I forget quite a bit. Okay, so let's see what we have here. Well, we know that we need a 4x. I know that already because the answer choices told me that's what I needed. Okay, let's follow through. So we have 4x to the third, great. And then we multiply 4x times minus 2. We need a placeholder under x squared. Oops. And then we will have a minus 8x. Minus 8x. Okay, so let's subtract this out. Well, of course, we get 0. This is 0. This is minus x squared. And then minus 8x is plus 8x. Bring down that 8x. Plus x. Excuse me, the plus x hanging on in the end there. Now let's go through this one more time. Well, we have x squared. And it's a minus x squared. So I know I need a minus 1. Well, that will verify option C is our answer. And let's go back to our calculator. And that is our pink y sub 2 choice. Graph it again. Perfect. But let's go ahead and finish our long division. Why not? We're here. Okay. And let's just kind of look at that remainder we're going to get. So we have -1, so that will be negative x squared, and that will be, oops, we don't have an x value, an x to the first. So this will be a 0 here, and then we get a plus 2, plus 2. Okay, so let's subtract this out. Well, the first one, that's 0. And then we have plus 8 minus 0, so that's 8x. And then 8 minus 2 is plus 6. And that's our actual remainder that we should get. Okay, looks like everything turned out just fine. 4x minus 1, option C, is a wonderful slanted asymptote going through our original rational function. Now, do take in mind that the TI-84's image is not going to always be super perfect, but that does give us an idea that we are correct. Okay. All right, this is the last question in this particular video. Remember, it's the second video of our Competency 7 quiz questions at the end of our section. Okay, and once again, thank you so much for watching, liking us, sharing us. And if you haven't subscribed yet, we encourage that you do. It'll help us keep our videos free and help us out too, so we can post more videos for you. Once again, happy testing.